Oh, water. So, I don't really know. Because I'm very confused. The reason I'm confused yeah. The reason I'm confused is because I've been reading about brick maps, and from what I understand, a brick map is just basically an octree, except that it doesn't split. Like, it skips that whole thing. It's just you've got the container and then you have the content. But because you have the container, you can check if the content has anything in it. And then you can skip the whole thing. And because you're doing this, you can ray trace a lot faster and stuff. But what I don't understand is that people keep talking about octrees as being like hard to traverse and access the data, but I don't get that. Because why don't you just, like, why are you storing the data in the leaf nodes? That makes no sense to me. Because you can just store the data in the octree, like in the root node. Like, that's where you store the data. And then you just use the leaf nodes to access it. So why would I need to do any of that shit if I wanted to access it? Am I just did I just make a brick map? Like, is that all I've done? Am I not using an octree? Did I make an octree brick map? I need someone to tell me what I've done. And in that case, I feel like I'm probably using I'm probably making them too deep. Because the thing is, if you're making it deep, right, you can, well, I don't know if it really matters, but the problem is that at least when I try to visualize it, like if you have a really big map, when you try to go through it, it'll always hit something. because there's always going to be something in like ground in it. That's what I'm thinking. And that's why I feel like it might be better to have smaller trees. But even if you do, because what it will spare you if you have smaller trees is that you won't have to go down and check. But it doesn't really matter because you have to go in and check anyway. Right? But I think what we should do now is well, I don't understand why the ray tracing is as slow as it is, to be perfectly honest. Let's make a little thing here. We have this ray check, right? What if we make a public pool world bounds? Okay. That'll take in a vector 3 position. And then we check if position.x is less than 0 or position.x is greater than should this be exclusive? I think so. It should be greater than world size.x. Yeah. Let's go with that. And then we just copy paste this shit. And we return false. Else we return true. Because that's one thing I'm worried about right now, that I am stepping outside of the world an absolute buttload. And I don't know how heavy each step is, really. It's probably not great. So this is where we set our step length. So let's do if step. Now if check world bounds world. What the fuck did I say? Check world bounds. Step. Step is... Oh, it's a float. Okay, we need current ray position. If that is true, then we do all of this, right? Else, break. I'm out. I'm out. Fuck off. Now, this will literally break it at the moment. So we can see if it just makes us not lose any frame rate at all. Now. I'm still losing a lot of frame rate, which is kind of weird. Because these rays should terminate themselves immediately. So where is the issue here? Exactly. I keep making a new ray here. And I keep having to do this. I wonder if I should make threads for this instead of parallel 4. Because with parallel 4, they keep recreating, like, or I don't know what this is called, redeclaring these. And it sounds really, really stupid. Because when I could be declaring this once inside here, making one new ray, we're actually making 1,000 rays here, which is stupid. About 1,000 frames, 1,000 rays a frame. But I don't know how to really use threads with start thread. That's the problem. And I don't really know how I would do this otherwise. Can I, like, somehow declare? Parallel.4 declaring variables. Yeah, I know that they are local, that's the problem. Well, can I... Can you get, like, a thread ID inside here? What are they writing here? They are typing parallel.4 long, and then they have 0 length We have this. J loop subtotal. The type of the third parameter is a funct result. Will store the thread local state. I mean the Y? Hmm. What if we type parallel.for? What do we have here? Parallel loop state from inclusive to inclusive. Parallel loop state. Got a bunch of different for longs and ints. That's pretty much it. Here's something different, but I don't think it's actually different. No. Cancellation token. Max degree of parallelism and task scheduler. That's it. Well, maybe we can do this. If oh, that doesn't work either. See, the problem here is that I don't want to be recreating these arrays every single frame 1,000 times. But I also can't use rays from outside, because it's the same ray. So how do I parallelize rays? Concurrent bag. The fuck is a concurrent bag? But I'm just... I don't know. Like, I just don't know what I could do to really make this run any better. Let's try a really shitty, really stupid solution. The heck of it. There, and then we set all our rays initially there, and then in this silly little for loop. Instead of setting an array like that, we're going to do ray. What did I call it? Ray list. X, Y. No. X. What are you doing? Oh, wait. Oh, wait, no. Set down here. don't need that. Let's see. Now, I don't think this will do anything, but it's worth a try, just to see how heavy it is to spam new ray every single frame. Didn't make much of a difference, I think. Now there's no difference. So what exactly is the issue? It's not the set pixels. This. What should be happening right now So I'm not sure you can do debug.log when you're paralleling. No, it's not saying anything. Because what should be happening here is that we're really just running for loop that iterates through the screen size. And it doesn't do anything. Like, that's what's happening right now. We're not doing anything. Because where's the camera? The camera, if we move the camera like really far up, there should be no way. It still runs at 20 FPS. Because all it should be doing now is this while loop runs while timeout is less than step limit. Maybe we need a step limit out here too. No, that makes no sense. Because what's happening is, while we are doing this, we increase step plus step length, and we set the current rate position to iterate its direction based on step. If I'm doing that correctly, I think I am, but I could be wrong. I'm multiplying the direction by our current step. That's it. And once we have done that, we do check world bounds, current rate position. And if this position is less than or greater than our world bounds, then we just cancel everything. Else, timeout plus step limit, break. And right now the camera is so far up that all of these rays should trigger falls here. Maybe if we do something like this. You'll see a little bit better what's going on. Is this triggering? It's not. That's really strange. So now we're not getting anything anymore. Oh, yeah, I didn't set this back. How about now? It doesn't work. Come on. Did I ruin now? Oh. That's it? Perhaps? Now we're seeing that. But it's still wrong. And I don't get it. What is happening? How? It's like it's not running this. And like unironically, it's like this is not the code that's being run. Because I'm not resetting the here in the color array, I'm setting the color array to be 0, 0, 0, 0, right? And in the raycast rendering, I haven't even done anything here. So this isn't even what's being used. And I'm only setting this to black once. So I'm not setting it anywhere else. Like over here. This is inside the raycast loop. This is the only place where I'm setting the color, and it's being set to the voxel type color. So this is only run when I hit a voxel. So how can it update itself to be black? does that make any sense? It should just, like, show the last thing that was there. Forever. See, like this. That's what it should look like now. And if I move the camera out, it should not turn to black, but it is doing that, and I don't get why. Because what should be happening is, whenever we hit, like, at the outside of the bounds, here I was setting that before. See? If I equals octree list.count, but this was when I was doing things differently. Here I was setting it to black because it was behaving like I am expecting now. And now I'm trying to set it to red. Maybe it is. Maybe it is. Maybe I'm stupid. This is a bite. It might be. It might actually be doing the correct thing. It was. Okay. My bad. Not bad. So now it's rendering red. And the frame rate is still dog shit. So where's the issue? Even if we set the step limit to 1. It still runs at 20 FPS on one ray. Or one step. The only thing that changes anything is, I think, changing the resolution. Yeah, the resolution is the only thing that affects how it's running. So right now, the issue has nothing to do with the raycasting, I think. Is this like a garbage collection problem? Man, I don't know what's happening. But no, it just says the octree controller update is now running at 47 ms. And I don't really know how to actually get any more detailed information. I am not really very good at this. But the GC seems relatively minimal. It's just the raycasting script. So, remove the while loop. It's still... Now it's gonna run well. No! The raycast is gone entirely, and it runs at 20 FPS. So, that's interesting. It's not the set pixels. It's not the parallel. It's not the new ray test. What the hell is going on? Let's unparallel it. Because when it's paralleled, it's too hard to debug it. Set this to like 2010 again. Otherwise it's gonna run like dog shit. If raycast, raycheck, right? That's the only thing that's happening there. And it's not just that we're doing a for loop. Well, it kind of is. I didn't know for loops were this heavy. Whoops. But even then, that's not nearly as much crap as we're doing down here. What if you put this in here? Yeah, that's it. How do you get past this then? I don't understand at all then. How do you make a raycaster when you can't even make a for loop? What? So we're not allowed to declare anything inside this for loop. Really, like, we can declare maybe one or two things, it seems. But we can't do more than that. This is gonna be a little bit tedious, but 1, 2, 3, 4, 5, 6, 7. Whoa! Oh, Crescenstein. Thanks for the raid. Everything's fine. Then I'm confused. Let's see. Where is it? There. If test 1. No, just do that. That, and then that, and that, and then that, and then that. I'm trying to raycast, but it's running at 20 FPS, and I'm not even getting any data or anything on the screen. Embedded statement cannot be declaration or what? You need the brackets there? I've never seen that before. Oh, that's so annoying. That's new, right? It's because it's a declaration, and it makes no sense, right? Because if you're declaring it, you want it for the local scope, but if it's just a one line, then there's no point. So I guess it's just that. But I'm just doing this to test this. So we're for looping. Yo, what the fuck? It's that heavy to just do these tests? Holy shit! It tests 4 and 7. 4, that's making new ray loop, or rays. Yeah? Yeah, but I'm not trying to do that actually. I'm trying to raycast 960 times 540 rays, which is still a lot, but it's not bottlenecking on the raycasting. It's bottlenecking on the declarations. That's what's wrecking me. It's not a Unity issue, to be honest. This is just pure CPU stuff. It wouldn't be any different if you were doing this in outside of Unity, I think. Look, what I've tried is, because I've been parallel looping it, right? So we have 8 threads running the raycasting, but to do that, you have to have a local ray. So for every Y iteration inside the X and Y, it has to make a new ray. And I was thinking, like, it sounds like a very bad idea to make like 1,000 rays every frame. So what I did was I made an array up here of rays. An array of rays. Array. And then we have a bunch of things to undo here. Undo. And then we bring that back. That, and then here now. Do that. These things also. Not great. UV equals new vector 2. And then here, instead of ray test, we need to do ray list xy dot direction equals direction. Need to replace that with the ray list. But if you set up the ray right before the loop, so the loop is just setting the variables instead of creating new rays, you can't do that. Because if you have a ray, like that's what I did first. I just made a global ray. And what happens when you parallel it is that you have 8 threads all using the same ray. they have to have the ray internally. So, and when you're paralleling using parallel.4, you don't have any space to like set up a local global variable. So every single y iteration here, because it's a nested for loop. The bottom here is the y, and then inside here there's an x. So the best I can do is I can set the variables that I need locally here inside the y, so it still re-declares them like 1,000 times if we're doing a 1920 times 1080 resolution, right? And yeah. I mean, there's probably some way of doing this, because like I was thinking you could do just threads instead of doing parallel.4, you could just do new thread. Have you asked GPT? I have not. But I haven't really used new thread before, and I don't really know how to do it well with a for loop either. Gave me the best LOD creation editor window yesterday. Alright. So this is an issue. UV, this should not be new, this should be .set. Then it needs to be like this. X divided by screen size X, and Y divided by screen size dot Y. Stop complaining. Why are you complaining? Unassigned local variable. Okay, this needs to be new equals vector 3.0. There. Lord ray position. That's something that needs to be set here. Like normally I only do 2D stuff, and the like processing overhead that you have there, or the processing leeway that you have there, is so massive that you don't really have to give a shit about anything. But right now we're doing 3D, and I don't know anything about 3D. So I've never had to care about like just counting whatever it's called, just operations. This also a problem, but you can do this without doing new color. You can do when you have a color array, you can access it using an array accessor like that, and then you can just set it like this, 255. So the problem here is that we'd have to cache this. I don't know if that's any better. Just trying to avoid doing any new, basically. But I don't think this is really... We haven't really changed anything enough that it matters. Let's change this back to like times 360 or something. Because we're not even raycasting yet. Like, I'm not even past... You know, just running the for loop. Now, what happens if I increase the step limit? Like, the raycasting itself is fucking irrelevant. Well, not necessarily. Because I'm doing this, right? Let's return true here. Always. Because it was returning false there, so it might actually matter. Let's see. Raycast, it's 20 FPS. Step size equals 2. 20. 100. 2000. 20,000. Okay, now that's the step size. Step limit, 10. Okay, it matters. Quite a lot. 100 steps is insane. But let's stop this then. Let's not do this at all. Because what I was trying to do was, I was just trying to raycast on the CPU just to get it to work and see how it's done. But we have to start figuring out how to do it on the GPU. And that means figuring out how to construct a brick map or an octree on the GPU. And I'm already tired from saying that. Shaders, create. Compute shader, ray tracing shader. What does that look like? My raygen shader. Render target. I don't get it. I know how compute shaders work. I don't know how that works. Now, what should the thread count be here? Be 4 times 4 times 4? 8 times 8, that's 64. So it needs to be... Most likely, yes. Yeah. Because then if you do... Well... I don't know if it matters. Whatever. We're using dispatch thread ID anyway. I don't even know where to start. Like, people keep telling me about using buffers, but whenever I look up buffers, every single time I look up buffers, all it shows me is how to set up, like, a constant bool. And that's it. So I get no information. I've never found any information telling me how to supply the GPU with lots of data via a buffer. So, like, maybe you just use an array or what? Like, but there's like no detail in anything. HLSL compute shader data buffer. Sending data to GPU compute shader. The easiest solution to passing 2 bytes to shaders is don't. Okay. Just pass 2 float values. Compute buffer is passed to the GPU as array bits that can be interpreted any way you want. What is array bit? Oh, nothing useful there. Whew. Compute shader array buffer. I'm currently trying to write a compute shader for ray tracing octrees. That's me. Which uses some kind of per core buffer. The buffer is only used to keep track of some data during this process. uint index buffer data buffer 16. The compute shader writes randomly to the buffer on the index and advances the index. The same goes for read, only that it subtracts the index. In theory, it should behave like a stack. This is what a simple write/read looks like. Cast stack depth plus plus equals data, data equals cast stack minus minus depth. So this gives me an error. Dynamically indexing such kinds of arrays can be problematic in shaders. Oh. You need to either rethink your algorithm or avoid writing to such arrays or use a group shared buffer. Group shared buffers are a special feature only available to Compute Shader, which is a dedicated fast memory which is shared by a Compute Shader group. I'll be right back. Oh my god. All right. Google HLSL compute shader group shared buffer. Group shared memory. Okay, so like it's completely impossible to find anything. Group shared buffers. Like it literally doesn't even give me anything. Is it possible to set the size of the shared memory of a compute shader workgroup from the host code? Oh. Group shared parameters for variable. Variable syntax. Extern. Group shared. Mark a variable for thread group shared memory for compute shaders. In D310, the maximum total size of all variables with the group shared storage class is 16 kilobytes. In D3D11, the maximum size is 32 kilobytes. So, what does that mean? Let's see. Did I close everything? No. uint 32t. What is that? Unsigned 32 integer. A vector containing 4 unsigned integers. Min 16 uint. So what's a uint underscore t then? We don't really have a choice. We can... What's a min? Min int. But either way, I think we should just be using uint then, I guess. Doesn't complain about that. But I still don't understand what a buffer is. Buffer type. So do we need group shared buffer uint test? Is that how that works? A buffer variable with a matrix as long as it fits in 4 32-bit quantities. For a buffer containing structs, use a structured buffer instead. A read-only buffer, which can take a T-type that is a structure. Doesn't seem to complain about that. But what does it mean? Like... Get dimension. Load. It's absolutely unreal how bad the Microsoft docs are. Like, it doesn't contain... There, maybe there's something there. New resource types. Structured buffer. A structured buffer is a buffer... Hold on. A structured buffer is a buffer that contains elements of equal sizes. Use a structure with one or more member types to define an element. Here is a structure with 3 members. Use this structure to declare a structured buffer like this. Structure buffer my_struct my_sb. In addition to indexing, a structured buffer supports accessing a single member like this. ISP27. So it's literally just an array. Read-write buffers and textures. Byte address buffer. A byte address buffer is a buffer whose contents are addressable by a byte offset. Normally, the contents of a buffer are indexed per element, using a stride for each element s and the element number n as given by s times n. A byte address buffer, which can also be called a raw buffer, uses a byte value offset from the beginning of the buffer to access data. The byte value must be a multiple of 4 so that it is d-word aligned. If any other value is provided, behavior is undefined. Data Model 5 introduces objects for accessing a read-only byte address buffer as well as a read-write byte address buffer. The contents of a byte address buffer is designed to be a 32-bit unsigned integer. If the value in the buffer is not really an unsigned integer, use a function such as asFloat to read it. A buffer resource is a collection of fully typed data grouped into elements. You can use buffers to store a wide variety of data, including position vectors, normal vectors, textured coordinates in a vector buffer, indices in an index buffer, or device state. A buffer element is made up of 1 to 4 components. Buffer elements can include packed data values like R8, G8, B8, A8 surface values, single 8-bit integers, or 4 32-bit floating point values. A buffer is created as an unstructured resource. Because it is unstructured, a buffer cannot contain any bitmap levels. It cannot get filtered when read, and it cannot be multi-sampled. A vertex buffer contains the vertex data used to define your geometry. Vertex data includes position, coordinates, color data, texture, coordinate data, normal data, and so on. The simplest example of a vertex buffer is one that only contains position data. It can be visualized like the following illustration. pp.p. Okay. I don't know what that means at all. It's dot dot. More often, a vertex buffer contains all the data needed to fully specify 3D vertices. An example of this could be a vertex buffer that contains per vertex position, normal, and texture coordinates. This data is usually organized as sets of per vertex elements as shown in the following illustration. This vertex buffer contains per vertex data. Each vertex stores 3 elements: position, normal, texture, coordinates. The position per vertex data. Each vertex stores 3 elements: position, normal, and texture coordinates. The position and normal are each typically specified using 3 32-bit floats, and the texture coordinates using 2 32-bit floats. To access data from a vertex buffer, you need to know which vertex to access, plus the following additional buffer parameters. Offset, the number of bytes from the start of the buffer to the data for the first vertex. You can specify the offset using the ID3D11 device context IA set vertex buffers method. Base vertex location, a value added to each index before reading a vertex from the vertex buffer. Before you create a vertex buffer, you need to define its layout by creating an ID3D11 input layout interface. This is done by calling blah 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 create input layout method. After the input layout object is created, you can bind it to the input assembler stage by calling the set input layout. To create a vertex buffer, call create buffer. Index buffers contain integers offset into vertex buffers. Are used to render primitives more efficiently. An index buffer contains a sequential set of 16-bit or 32-bit indices. Each index is used to identify a vertex in a vertex buffer. An index buffer can be visualized like the following illustration. Offset, start index location, index count. The number of bytes from the base address of the index buffer. The offset is applied to the setIndexBuffer method. But like compute buffer. Get type, set counter values, set data. Get native buffer pointer. End write. Set buffer. Okay, so the key, from what I understand, is you need to be able to set data that we have properly packed into a buffer. And then you need to figure out how to read that on the GPU, basically reconstruct the scene that way, and then raycast on the GPU. Because we can't even for loop through properly. It's just too much. What the fuck next? So how are they doing this? Solid nodes in the brick grid. Brick maps are the core of our data structure, and together they form the actual representation of the data. We empirically determined a good size for the brick map to be d to the power of b equals 888. Since brick maps represent fine detail which can be random in nature, the size of the brick map is equal in all dimensions. Given this size, 512 bits are required to represent the solid data of the brick map. Yeah, so... Shut up. So this is a bit mask that just tells you if something contains something. That's it. And that's exactly what I was doing in my octree. Here, where whenever I set something, I set my content switch based on the index of whatever we're setting. So that way we had an 8-bit mask that just told us, like, if all of these are off, then this is empty and we can skip it. And that was pretty much it. And that's what they're doing here. I don't really understand what this means. Like, they have a 32-bit color pointer and 24-bit LOD color. Now, what does that mean? We store shading attributes such as color separately because a relatively high number of voxels are empty and have no shading attributes. Instead, the brick map contains a pointer to an array where these attributes are stored. Finally, the brick map data structure contains a level of detail color which is used in case the brick map is out of LOD range. See, this is what's confusing me. Like, they've got 3 bytes of the pointer. I didn't know you could have, like, bytes in a pointer. I thought pointer was just like a reference, but... Shading attributes are stored separately from the brick maps. In our implementation, we only store color. The voxels are rendered as cubes, so normals are derived implicitly. The color data is stored in a compressed format based on S3 color map compression, specifically DTX1. DTX1 stores 16 pixels in 64 bits of data, giving a compression ratio of 1:6. Applied to voxels, this averages out to 4 bits per voxel. I don't really understand what the hell they're saying. Like, they're talking about storing color data. Store 16 pixels in 64 bits of data. 4 bits per voxel. But I don't understand what this means. Like, what is a color pointer? What are you pointing to? How can you have 32 bits of colors when you have 512 voxels? Like, what does that mean? Like, what the fuck are you talking about? What are you coloring with this? Are you just coloring like all of these? You using like one color here? Is that what you're doing? Like, I don't get it. We store shading attributes such as color separately because a relatively high number of voxels are empty and have no shading attributes. Instead, the brick map contains a pointer to an array where these attributes are stored. Okay, so this is literally just a pointer to something else, like to an array. That's what this is. It doesn't actually contain anything. And then you can access that array using these byte indices. More or less. Yeah, no, you can, because we are using 512 here. So it actually makes sense there. Because, like, if you have... We're not setting how many we have, we're setting which ones we have. So if this is flipped and that is flipped, and you want to access that, then you just use those. Because you know that that's... Well... No. It's not. Hmm. $512. Wait, how does this work? 512 bits. Yeah, so it is using up all of this. Like this. And it's using them separately. It's not using them to count a number. So if number 4 is, or this is number 3, is true, then you can just access an array using 3, and then you can get the color of that. I guess, something like that, but how do you do this? Like, how can I create a buffer that contains a pointer on the CPU and send that to the GPU and have that pointer make sense? Like, I don't understand pointers, to be honest. Especially not in this context. I mean, I do understand pointers, kind of, but not here. Because the GPU would have completely different memory, so how can you reference that memory from the CPU? I mean, maybe you can. Like, in my octree, or rather, in my nodes, we have content switch here, and this is just a byte. So the difference here is that I'm using a bit switch or bit mask, I guess that's what it's called, for every single one of my nodes, but they just have one big brick, so as it's called. And that contains information telling us whether anything inside contains anything. Let's see. There were, I found some websites at need to remember to save. Where did it go? Good question. There it is. Looking at this, so this is a brick map, I guess. So this would be a brick, and then this inside here is just voxel, or it. Yeah, yeah. And I honestly think that the brick map is pretty much identical to my octree. Except that it just has more children straight away. Like instead of 8, it's 8 times 8 times 8. But I still don't really get the difference. I must be misunderstanding something gravely, to be honest. Because I don't feel like this is technically a data structure, and I guess that's what's weirding me out. Like, I don't know, because what people were telling me was that, or what I've been reading, is that the octree is slow because you have to access the leaf nodes by going through the tree. But I don't understand why. Why you have to do that? Why does the data have to be stored in the leaf nodes? Because I was just kind of using it as a way to not to store data, but to create a way to skip data. Rather. No comedy, irony, death for me? Yeah. Were you really sick? Or was it like completely manageable? That's my question. It didn't seem like you were dying that heavily. Was the flu? Yeah. It's like here in the octree, I've just got the data I had, and now I have nodes instead stored here. Then the node contains the voxel. And the reason I did that instead was because I made all the nodes contain voxel data. Okay. Make a new script. Something is wrong. What were they calling it? They weren't calling it a brick map and brick grid. Every cell of the brick grid contains a pointer. A pointer either points to a loaded brick map, an unloaded brick map, or is an empty pointer. I wonder how hard this is to do in C#. Like, maybe I have to turn on unsafe code. So pointer heavy. But what I was thinking here was... And I'm so lost on this, dude. So a brick map... Damn it. I don't know why this is so hard for my brain. Size of the brick map, blah 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 blah. The data structure consists of exactly 71 bytes. The exact layout can be seen in figure 1. How do they reach 71 bytes? 112 plus 32 plus 30. No, wait. What? Oh my god. $71, yeah. So how do I make a 512-bit byte mask? Like just here. That's... See, that's the problem, like... Let's see. C sharp bit mask. How do you declare a bit mask? Is that something you can do? Bit vector 32 create mask. Creates a series of masks. Bit vector 32. Bit array. Bit vector 32. Oh, it's a bit vector. Hmm. This. How would you do this? Well, maybe it's an array. Or something like that. Because this makes no sense, right? Though, it would be ideal if you had that many bits just in one row. So we can have a uint 64. Apparently. I'm just thinking. Like, how would you do it? one brick map contains 8 times 8 times 8. No. Yes. This, I don't know. Why is this like going straight through my brain? We've got the brick grid, and this entry in the brick grid contains a brick map that looks like this, and each point in the brick map is a voxel. So yeah, I want 512 bits. How do I get 512 bits? Like, I want the masks to just be one continuous string of bits, preferably. Bit array. Instantiating a big integer. Hello? Wait, let's go for a bit array. It's 512. How you doing? But the thing is, well, hello, Biblio. Yeah, we're doing work on a Sunday. But this is a personal project, so does it count? See, what I liked about using a bit mask, or just a bitwise on an integer, was then you could just check like equals 0 on it, and you just instantly get the result. Like if it's greater than 0, then it contains something, otherwise it doesn't. But the point here isn't to figure out if something contains something. The point here is to just figure out how to store data that we then can send to the GPU. But I don't know. I still don't know how to send this information to the GPU. I worked 2,340 hours last year. Isn't that like a normal work year? I don't know how much you'd end up working. I think 2,080 or something. But that's excluding holidays. So yeah, I guess you worked a lot. Must really enjoy clearing out those ditches. How come you're working so much anyway? Just a lot of stuff that had to be done. Hopefully I have time for some vacation this year. Yeah, hopefully. Hmm. No, I said bit array, not byte array. No, not a byte array. Because I don't really understand how to make any sense of this. For the GPU, other than storing it as like a shitload of integers. What's 8 times 8? That's 64. So if we use 64-bit integers, we only need 8 of them. And then we could just call them like Z0 to Z7. Does that make any sense at all? This is what happens when you didn't study computer science. You're trying to make GPU ray tracers. Yeah. Oh, Thelonious. I'm dying. Oh. I don't know programming, and I'm trying to figure out very, very complicated things. For example, right now, I'm trying to figure out how to store these voxels as 512 bits side of the data structure, and it's really hard. Right now I'm trying to store them as 8 64-bit unsigned integers, because the data structure is 8 times 8 times 8 voxels, right? So that's 512. So if we have 8 times 8, we have 64. So that's an unsigned 64-bit integer. And that way we can store 8 integers. I mean, I could store them as an array, of course. Or I could have a 3D array of integers. That even makes sense. Oh, it wouldn't. Because we need bits. Yeah. And then the idea is that if we just have empty voxels, right? Then if I have a voxel in 0, 0, 0 in XYZ, and I place a dirt voxel there, then every single entry, like x1, x2, x3, is assigned 1 bit. And if there's something in there, then you flip that to 1, and that way you can tell that there's something in here. And if you have an integer, or if you store it like this, then to check if there's anything at all in the brick map, you just have to check, like, are these 0? Because if you flip a bit, any bit, it gives you a value. So if all of them are 0 and we just check is this 0, then you know, yep, this one is empty, and then we can just skip the whole brick map when we're raycasting. Yep. But like I said, right now, I just need to be able to store the information. And then it says that it wants a color pointer. What the hell does that mean? A color 32 is a struct. So I can't just do that. Also struct. How would I... It would have to be a class. Something. Don't really get it. Every cell of the brick grid contains a pointer. A pointer either points to a loaded brick map, an unloaded brick map, or an empty pointer. Blah, blah, blah. Shading attributes are stored separately from the brick maps. In our implementation, we only store color. The voxels are rendered as cubes, so normals are derived implicitly. The color data is stored in a compressed format based on S3 color, or S3 color map compression, specifically DTX1. DTX stores 16 pixels in 64 bits of data. I don't know what that means. What pixels are you storing? 4 bits per voxel. This compression is done in blocks of 16 colors. Object pool buffer. Color data is a more complex system. I don't really get it. There is a GitHub project for this too. Or is it? I have too much stuff open. It's for CUDA, I think. And I don't really understand any of this code in here. One important improvement is that the paper does one allocation per brick, 8x8x8 voxel block on the GPU. Instead of using pointers, we can simply use indices that index into a linear block of memory. When due to the streaming system, the block of memory fills up, we simply double its size, allocate a bigger memory chunk and copy the old bricks. To keep the index small and further improve data locality, we divide the world in super chunks, each composed of 16x16x16s. Normal 8x8x8 bricks, which means that the maximum index value is 4095. 16x16x16, which only takes up 12 bits. The standard size of the brick storage for a super chunk is 256x64 bytes, which would fit one surface worth of bricks, 16x16. We double the storage size every time it fills up, so 256, 56, blah 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 blah. When an array hits a brick that has not yet been loaded by the GPU, it will add the request to a request buffer. The CPU will then upload the brick to the GPU. This way, only bricks that lay on the surface of a super chunk will be loaded, since rays won't penetrate into the inside of a super chunk. Since the super chunk contains 4096 bricks, 16x16x16, we only need 12 bits for an index, which leaves us with either 4 or 30 bits depending on whether we use 16 bits or 32-bit index. 3 of these bits are used for flags for the streaming system, brick loaded, brick unloaded, brick requested. Since there are no hardware atomics for 16-bit integers, data types, and rolling our own would be slow. We used a 32-bit index. By using a 32-bit index, we are left with 17 bits that we can use for other purposes such as 2x2x2 LOD, which only uses 8 bits. In total, there are 3 LOD levels, 8x8x8, 2x2x2, 1x1x1, which is the finest. Rendering performance-wise, I saw no big difference in frame rate, frame times / rate, but the number of chunks requested to be streamed did decrease significantly. Unfortunately, CUDA does not offer access to the hardware accelerated ASTC/DXT1 texture decompression, which I could use to store colors per voxel. This would mean that I would have to write a software decompressor, which would probably be a lot slower. Voxel terrain data is inherently well suited for these types of texture compression, as they are often gradient-like in color. Maybe some type of specialistic voxel color compression system could be devised for this. This is C++, and I don't understand his project. Ray queue. Allocate ray queue buffer. Ray buffer work. CUDA malloc ray buffer. You know, that didn't tell me anything. Struct supercell. A supercell int GPU count equals supergrid starting size. Got a vector of bricks, vector of indices, a vector of GPU indices. GPU indices location. Brick pointer, GPU brick location. To the stream T load stream. Include chrono. Okay. On a trigger. Okay. Morton on code. Mathematical analysis and computer science. Functions which are Z-ordered, Lebesgue curve, Morton space curve, Morton order, or Morton code map multidimensional data to one dimension while preserving locality of the data points. Yeah. Copy supercell content to GPU. Vector, brick pointer, GPU supercells. GPU super indices. For auto at I colon supergrid. No idea what that means. If I pointing to indices j and brick loaded bit, temp indices j equals brick unloaded bit stick I indices j and brick loaded bits. This is a vector of integers. GPU.supercells.pushback null pointer. CUDA malloc GPU supercells.back supergrid starting size. CUDA memcopy GPU super indices.back. CUDA memcopy hosted device. Copy pointers for supergrid to GPU. But see, this doesn't tell me anything, because all it's doing is it's just calling CUDA, and CUDA is mallocating, which is memory allocation, and memcopy, and that's it. Like, it doesn't tell me anything. Back. Okay, so someone put a octree project for Unity up on GitHub. Now, he has an octree shader here. Texture 3D int volume. Geometry raycast. Ray origin, ray direction. Oh, he has that in here as a texture coordinate? If unity matrix P33 equals 1. This is the vert? And the frag. Its volume dimensions. Ray. If cast ray. Which computer language is this written in? This is probably HLSL because it's a Unity shader. Oh, that's what it was. It does this, and then in here it's going to do It does do while. Maybe I should do while loops instead of for loops in my shader. Oh. File type equals pointer underscore type. Right? These are not really the things I really want to understand, but mesh to octree. Predictable renderer feature. Excuse me? The fuck is that? Scriptable render pass. Okay. Fine. For each var in... What are you doing? That's not doing anything. Private octree render pass. Render pass. Create render pass, new octree render pass. And that's this. But it's not doing anything. Unsafe int as int float f. Why are you like... He's doing pretty much what I'm doing, but it seems so complicated. He's still like, he's like clamping and shit, like just... I don't know. Hill triangle. Well, I'm just trying to figure out how in general they store or send all the voxel information to the GPU. There's so much shit. I don't know. But this, the fact that he is setting them as, or was it? You have cast ray, fill triangle. The fact that he's setting as triangle makes me wonder if he's doing some kind of meshing, and the fact that he has mesh to octree. No, I don't even know what that means. It's just a meta, mesh to octree. So I think his idea here is that he's turning meshes into octrees and then I'm not sure. Set the texture of a material using an octree shader, yeah. Yeah. So I think he's not doing a GPU method exactly. He kind of is, but he's using the vertex shader to carry over everything as vertices, which is, in my opinion, just meshing. It's basically impossible to find any information. Like, I've been looking up buffers and shit all day. And I think a structured buffer kind of does what we need. But I don't really know. Something like this. Like here we can get a bite out of it, but you indicate that you want raw access to a buffer or a raw view of a buffer when you call one of the following methods to create a view to the buffer. Shaded resource view disk, blah blah blah. Nah. We'll see. I might stream more tonight, but I think I'm gonna go and make dinner and then try to piece together some more information. It's just really weird. Like I can understand textures and stuff. Dealing with that, but I don't want more coffee. But once we start dealing with like pointers and bits and bytes, I just don't know how to send it to the GPU and like structure it and read it in a way that makes any sense. And finding any information or write-ups about it is impossible. Like even these GitHub projects, you just use CUDA and then it just kind of says CUDA do this and then it does that. I don't know. But I'm gonna see, because brickmaps seems really sparse when it comes to information. So there might be more about the octree. I don't think Carmack knows shit about this. Anyway, that'll be that. I'm gonna make some ground beef. I'll see you guys later. Thanks for hanging. Bye bye.